All right, hey stats. This is the last little bit of chapter 10 that we will look at. You won't have a test over chapter 10, but we're going to do this little bit. It's kind of a little project kind of based off of some of the data that we've collected on you guys in the past. And then we'll start on a few sections from chapter 11, and then go from there. So there is three pages, like a front and a back, and then a staple page that goes along with this activity. And so I'll just kind of walk you through at least the first one, just to kind of get you started. But the stuff that we're looking at is, I don't know, you guys collected some data a while back on everything. So this is the stuff that we're going to use for our semester project. So height, wingspan, foot length, shoe size, all that good stuff all the way across. For today, we're just going to be using height, foot length, shoe size. That's the only three things that we're going to be looking at. Okay, and we're just going to be doing linear regression tests with them. Okay, and we're only going to be doing 2 variables at a time, so it's not the multiple regression like what we would do on the computer. Like with the the StatCrunch software, you will still use your computer and do like a Google Sheet with it, but we won't do the StatCrunch software with this stuff. And so what they're wanting us to do is we're taking all of your guys' data, and in number 1 in particular, I'll walk you through number 1, and then number 2 and number 3 on the back side is going to be very similar to that. So I'll have you guys do that one on your own. But number 1 is taking this data and it's comparing foot length and height. Okay, so maybe start by circling those. And the thing that we want to make sure we pay really close attention to is that the foot length has to be the X variable and the height has to be the Y variable, okay? So if you're going to put this into a Google Sheet, which you'll need to make a regression equation, we want foot length to be X and we want the height to be Y. So you can go in and switch it on the Google Sheet where your X is the right column and your Y is the left column. But what I would do is if we know that going in and we know that this has to be X and Y, I would make this column go first and then this column go second. So when you're typing those in to make your equation, make sure your X column is going on the left and your Y column is going on the right. And then you won't have to go in and manually switch that or find out how to switch that. Maybe you guys know how to do that really easily, but I would just do that ahead of time. Okay, so what they're wanting is in part A, find the regression equation that relates your foot length to your height. Okay, now foot length is sometimes related to your height as far as it goes from little kids up through adulthood, but as far as you guys who are, most of you are getting toward full grown, you've kind of stopped growing. Some of you guys have the same shoe size, but there are way different heights. So in some regards, foot length doesn't necessarily, for you guys at least, represent height. But I went ahead and I put this onto a Google Sheet, okay? And so I put the foot length as the left column and the height as the right column, okay, because we want X and Y. And then it went ahead and spit this out. So it is following a decent linear regression. Those dots are pretty in line with each other, so that's not too bad. Our R squared value, I don't know if you can see this very well. I'll zoom in on this. R squared value is 62, it's 0.62. And again, that's R squared. So that means that 62% of our data is following that linear trend, which is decent. It's okay. We'll find out here in just a second what R is specifically, but I'm going to go ahead and I'm going to take that equation and I am going to transfer that back over to our Google Sheet here to find the regression equation, okay? And instead of using X's and Y's, I'm going to use what they're actually called. So foot length was my X variable, so height is my Y variable. So I'm going to say height is equal to, and I took a picture of the equation, 3.83 times the X, which I'm going to call foot length, so I'm going to say FL, and then we have plus 31.2. Okay, so your height is taking your foot length, whatever that is, times 3.83, and then adding 31.2 to that. Okay, I'm going to write down R squared. R squared is 0.625. Okay, and then from there, we're going to use that information to go down to part B and tell whether that tells us that we're related or not. Okay, so are those two things related in a linear pattern? That's what we have to decide. Are they linearly correlated, or do they have nothing to do with each other? Okay, and is that linear correlation strong enough to say that they're linear? Okay, so we got to fill these things in. I kind of outlined this stuff for you, and first things first, the the symbol that we use for H0 and H1 is P for some, no, is it P? I gotta go back up and look. Now I'm having a brain fart. I don't remember. P, I want to say P, but I don't think that's quite right. Now that I think about it. Why am I not thinking about this? Let's go over. Let's go to chapter 10. 10:1. I'm just brain farting on this. It's not B. Let me see here. It is P. Yep, it is P. Okay. So I don't know why I was thinking it wasn't P, because P is what we use for percentages. So, okay, well, all right, whatever. Now I just have to make you dizzy going back to where I was before. Okay. Let's see where we're at here. Good heaven's sakes. Okay, let's go. We're all the way down here at the bottom. There you go. Okay, we're back. So P. All right. I don't know why I was thinking it wasn't P. Maybe because her percent. All right, so P, and we're going to say P equals 0, and P is not equal to 0. All right, if P equals 0, then that means there is no correlation. Okay, because if we consider our value, our R value is going to live between -1 and 1, and a bad R is considered anything close to 0. So no correlation if P equals 0, but there is going to be, yes, a linear correlation if it is not equal to 0. Okay, so if it lives on the tails, and we have 2 tails going on here, and we have 5% that is living in each one of those. So I'm going to write that down over here, and 0.05. Okay, our N value is how many people we have in the class, which I think is 14. We should have 14 of you. I count 2, 4, 6, 8, 10, 12, 14. Yep. Okay. So 14 for N, and then the R value I'm going to base off of this guy here. So what our R is according to what they spit out. So let's see what we got. We have, if I take the square root of that, it should give me R. So square root, and 0.79 is what I get, which is decent. Yeah, that's not too bad of an R. All right, now we have to compare it to something. So we need to look up on our little handy dandy chart here, that little skinny sheet of paper that you have that tells us what is deemed appropriate for an R. So we have 5% and we have 14 is our N. Now, again, we're not doing degrees of freedom, so you don't subtract 1. 0.532. So anything that's above 0.532 is deemed acceptable, which seems like a really low threshold. 0.532, or, excuse me, if it was below a negative 0.532. So we are all the way up here, which means that we are away from 0, which means that P is not equal to 0, which means, yes, there is a linear correlation between foot length and height. Kind of like we said, you know, like they are pretty well related, get to be less related when you get into adulthood because, you know, like your feet don't always end up the same as your height. They do in some regards, but anyway. All right, part C is a part that you're going to have to do on your own, and everybody's answer is going to be different. So I will know if you cheated off of somebody else, I suppose. And you're going to use this equation right here, and you are going to use your foot length. Okay, so your foot length, and you're going to put that into your regression equation. Okay, this should be very, very easy, and it's going to spit out what your height should be. Okay, so whatever your foot length is, you're going to plop that in here to this little guy, and it's going to spit out your height, and then I want you to write one little sentence or one little statement that compares it to your actual height. Like, oh, mine was pretty close. It was this, and my actual height is this. Or, nope, that was not even close at all. I should end up being... or I should be taller than I actually am, or it's saying that I should be shorter than I actually am. Something of that regard is what you're going to look for part C, okay? All right, now, on the back side for 2 and 3, you're going to do that same process again, except you're comparing foot length and shoe size, and the first thing that you need to do is we're going to separate the data out, boys versus girls, okay? So boys are only going to have like 5 5 pieces of data. How many boys are there in our class? 5 maybe? 5 pieces of data. Girls, you're going to do like 9 pieces of data. So, and what you're going to do is you're going to take this table that we have from the front side, and you are going to just pull out whatever you are. So if you're a boy, you're going to do the boys' data. If you're a girl, you're going to do the girls' data. And I have room for you to put that right here, okay? So for like boys, you will start by writing down all of Jake's information, all of Clayton's information. Am I skipping over somebody? Clayton's information. Cray's, Marcus's, those people. So 4 of them. Down here, and you'll use those 4 pieces of information, okay? Girls, you do the same thing, but just for the girls. And so then girls and boys, you're only going to do foot length and shoe size for your gender, right? For if you're a boy, you're doing a boy's equation. If you're a girl, you're doing a girl's equation. And the reason why we do that is because, you know, boys and girls biologically are like, you know, like taller for boys and shorter for girls. That's just the way that it works out. So rather than lumping you all into one pool, we can get a more defined equation by separating you out into 2 separate groups, and we can maybe get some more accurate answers by doing it that way too. So we're comparing foot length. So again, that's the X variable. So when you go to put that in a Google Sheet, I would put that on the left side. Shoe size is Y, so that would go on the right side. Find the regression equation, and then pull out all your information that you need, just like we just did. And then again, part C is using your individual information from this table, like using your shoe size, what is your foot length, or whatever it is we're comparing, okay? And tell me like a sentence about how does that compare. It's pretty spot on. Nope, I should actually have a bigger foot than whatever, you know. All right, and then number 3 is height. So same thing, just with your gender. Just with this data, you're comparing height, and then you're comparing shoe size, X variable, Y variable. You're doing the same process again, okay? The very, very, very back page is something called a residual plot, which we have not done yet, but a residual plot is good for looking at like discrepancies amongst like what the data should be versus what you actually get, okay? So I'm going to take that equation that we got from problem 1. It says it wants to use from problem 1, so we're using the data as a whole. Let me put that equation back up again. We have that height is equal to 3.83 times your foot length plus 31.2. Okay, so that was our equation from problem 1. And what we want to do, I'll do this first one, we'll do Taylor's together, and then I'll just kind of show you how to plot it on a residual plot, and then you're going to analyze that data, okay? So residuals is like what your discrepancy is. So think of residual as discrepancy. It's like the difference between what it is and what it should be, okay? So Taylor, she's probably already done this with the equation up above in problem 1, but we're going to check her answer and see if she's right. So for her part C, she should have gotten, if her foot length is 8, I'm going to plop 8 into here for Tay, okay? 3.83 times 8 plus 31.2. And that is 61.84, okay? So that's what she should have gotten for a height. She is actually taller than that. So according to her foot length, she is actually taller than what she should be. So either she is just really tall or she has really small feet. So, you know, like according to what our equation is spitting out to us, okay? So what we do now is for our residual, we take the observed one, okay, minus the predicted. So predicted is this column, and the observed is this column. So we take this one minus this one, and we get a residual, okay? Now, some of you guys will be a positive number, some will be a negative number. So 66 minus 61.84, and we get 4.16, okay? So now, okay, that's fine. So now, foot length, she was in an 8 foot length, and her residual was 4.16. So 8 right here, we're going to go up to 4.16. So this is the dot for Tay. And you don't necessarily have to label these as who they are, but it's just going to kind of be fun to see. So there's where Tay lives, and we're going to look and see like how this stuff scatters out for your residual plot, okay? So are the people who are size 11s closer to the line, which would mean their like heights are pretty well accurate with like, if you have a big foot, you're really close to what your actual height should be. Or if you have a smaller foot, are you really far away for what you should actually be? So this residual plot can tell us kind of some information based upon that. So it's just graphing like the discrepancy. So really Tay should be like right here on the line. She should have like a difference of 0. Like these two numbers should be exactly the same number. But it's not, because she's like way taller than what she should be, I guess, which is not bad. So yeah, just graphing residuals and seeing how that data breaks down, and then we can, analyze stuff with that. So that's a residual plot. So that's the backside. I hope that all made kind of sense. If not, help each other, but make sure that you are like on each part C, plugging in your own data and spitting your own data out and writing a sentence to compare how it actually compares to what you actually had. Okay? All right, that should do it.